Hello and welcome to Geometry Weighted Averages. In this video, we will use weighted averages to locate points on the number line, on the coordinate plane using coordinates, and for real-world scenarios. Here are some of the standards that are going to be covered in our video. These are from the Florida's Best Standards for Mathematics. So a weighted average is the average of a set of values, but the values have different levels of importance. We actually use this when we are calculating grades. So thinking about how I calculate grades for geometry, we know that homework is 15%, classwork is 25%, and then formative and summative assignments are 30% each. And so that means that a 90% on a homework assignment is not the same as a 90% on a test, because a test weighs more because it's a summative assessment. And so we know that we've worked with weighted averages before. We kind of understand that some things have more value than others. So to calculate a weighted average, we're going to take the sum of the weighted locations and we're going to divide by the sum of the weights. And so a weighted location is just a location times the weight of that location. And this is going to make more sense when we start to plug it into the formula. So let's go ahead and get started. So our first question says, find the weighted average W if point A weighs 3 times as much as point B. So first we're starting off with points on a number line. And so it says point A weighs 3 times as much as point B, but it doesn't really say what the weight of point B is. When you go to set up your paper for this, first let's list out the locations that is being talked about in this particular problem. So they're talking about location A and location B. And then right next to those, we're going to put the weight of A and the weight of B. And so when we set up our paper side by side like this, it makes it a lot easier to plug into our formula. So A is at -5, B is at 6, so the locations are coming straight from the number line. And then it says point A weighs 3 times as much as point B, but it doesn't say the weight of point B. So I want you to make a little note. Usually with these problems, if it does not say a weight, I want you to set the weight at 1, and then we can have a basis for all of our other weights. So point B is going to have a weight of 1. And remember, the weights have nothing to do with the location. So we're looking at the description for our weights. And then it says point A weighs 3 times as much as point B. They're talking about the weight, not the location. So the weight of A is going to be 3 times the weight of B, which is 1. So it's just going to be 3. Now from here, we're going to plug this into our formula. So when I write my formula for this one, my weighted average, which is going to be W in this case, that's just a random letter assigned to the weighted average for this problem. W is going to be the sum of the weighted locations. So we're going to do A times the weight of A plus B times the weight of B. And then we're going to divide by the sum of the weights. So we're just adding what we put in parentheses underneath. So we're just adding the weights together. And so this turns into -5 times 3 plus 6 times 1 divided by 3 plus 1. And so this is why I also set up my paper this way. We have -5 times 3 plus 6 times 1. And so organizing my paper this way just made it easier for when I have to go and plug these in. And then my weights are being added up at the bottom here. And so this is why I set up my paper this way. All right, so now from here, I'm going to go ahead and plug this into my calculator. When we plug this into our calculator, it looks very, very much like our section formula. And the section formula, we covered in another video, but it actually achieves the same thing. It's just how they go about it changes a little bit. But we're going to use the calculator in the same way. So I'm going to go ahead and clear out my calculator. I have 5, and then I'm going to make it negative, times 3 plus 6 times 1. Notice that I'm not putting in parentheses in this particular calculator. If you put parentheses in this calculator, you have to put a multiplication sign in between your number and the parentheses, which kind of negates the use of the parentheses anyway. So in this case, we're just going to type it how we would read it, negative 5 times 3 plus 6 times 1. And that gives us negative 9. And then underneath we have 3 plus 1, and that's going to give us 4. And so negative 9 divided by 4, and so that we can put in here, and we get negative 2.25. If we were to try to reduce this, if I hit second F to D, second ABC, I still get the same thing. So negative 9 over 4, which is the same as negative 2.25. So that's about here. And so this would be W. And what they're saying is point A weighs 3 times as much as point B, so it's pulling the weighted average towards A because A weighs more. It looks the same. It achieves the same thing as the section formula. It just goes about it in a different way. But it's pulling towards the point that weighs more. And we'll see that a little bit more when we get to real world scenarios. And so this would be our answer for this particular question. All right, with this one, it says find the weighted average W if point D weighs 2 times as much as point E and point F weighs 4 times as much as point E. So we are looking now at 3 different points. We're looking at point D, which weighs 2 times as much as point E. We've got point F that weighs 4 times as much as point E, and then we're also looking at point E. So we've got D, E, and F, and then I'm going to list the weights right out next to them. So we've got the weight of D, the weight of E, and the weight of F. And let's go ahead and start with the locations. So D is at negative 4, E is at negative 2, F is at 3, and now let's get into the weights. So point D weighs 2 times as much as point E. Point F weighs 4 times as much as point E, but they never said what point E was. So I'm going to set point E at 1 because all of the other ones are in relation to E. And so point D weighing 2 times as much, so 2 times 1 is just 2. And then point F weighs 4 times as much. Remember, this has nothing to do with the locations. They're talking about the weights. The weight of point F is 4 times the weight of point E, not its location. All right, now when I go to write out my formula, remember we're taking the sum of the weighted locations. So I have D times the weight of D plus E times the weight of E plus F times the weight of F, and then we're just adding all those weights underneath. Don't forget this part. Some people do the top part and then they kind of forget the bottom. And so now, because I set up my paper this way, this makes it easier to plug in. I've got -4 times 2 plus -2 times 1 plus 3 times 4. So this makes it easier for me to set up. Also, you do not need to put these in any certain order. If you had listed F first, then E, then D, it doesn't matter as long as you're pairing them with their respective weights. So it doesn't matter which ones you put first. Section formula, it matters. Midpoint formula, it doesn't matter. And then with weighted average, it doesn't matter as long as you're putting the weight with its location. All right, so we've got -4 times 2 plus -2 times 1 plus 3 times 4. And then we're going to add all of the pieces that we put in our parentheses. So all of these here, all of my weights are going to be what I'm adding up at the bottom, like that. All right, and so with this as well, notice that we've got a positive and a negative right next to each other. If you want to take out the positive and just keep the minus here, that's totally fine. If you're plugging this into your calculator, it's not going to change it. So even if I left this as plus -2, it doesn't matter. So here we've got 4 negative times 2 plus 2 negative times 1 plus 3 times 4. And I get 2. Even if I just put this as -4 times 2 minus 2 times 1, I'm still going to get the same answer. So this is going to be 2. And then 2 plus 1 plus 4 is going to be 2/7. And so 2/7, if you need to kind of put this in your calculator to help you with kind of visualizing how to put that on a number line, this would be 0.28, which is kind of close to 1/3. And so W would be about here. Okay. And so this is how you would solve this one as well. So notice that with weighted averages, these aren't necessarily easy to guess. So when you guys are taking your EOC, this is something where you need to know the formula. They are not always going to be nice, pretty numbers with nice, pretty decimals. And so you need to make sure that you're learning your formulas. This is not an answer that I would easily be able to just kind of guess and stumble upon the correct answer. Now let's get into what it looks like for coordinates. So very similar to what we did with the midpoint formula and the section formula, where you're taking the exact same formulas, but you're just doing them separately with the x's and then with the y's. So same type of deal with this as well. All right, and so with this one, we've got P and Q. And so I'm just going to list those here. I've got P is at -4, -3. And then I've got Q at 4, 2. And then I'm just going to label these as X's and Y's just to kind of help me remember. And then I've got the weight of P and the weight of Q. And now I'm going to read our description. So it says, find the weighted average R if the weight of point P is 2 and the weight of point Q is 5. So the weight of P is going to be 2 and the weight of Q is going to be 5. Sometimes they just tell you straight up what the weights are, so that makes it a little bit easier for a problem like this. All right, now with these, we're going to do the same formula we did before, but we're going to do the X and Y separately. So our average, our weighted average is going to be R. So the x-coordinate of R, we're going to do the same thing as before. We're going to have P, but the x-coordinate of P times the weight of P plus the x-coordinate of Q times the weight of Q. And then on the bottom, it's the same as normal. We're doing the weight of P plus the weight of Q. And so we're just using the x's for this first part. So it's going to be this, my x-coordinate, times the 2, plus the x-coordinate times the 5. Same deal as before. And notice that how I set up my paper kind of helps guide me with how to put this into the formula. And then we're just taking our 2 weights and we're adding them at the bottom like that. And so now I'm going to go ahead and plug this into my calculator. Let's clear it out. We've got 4 negative times 2 plus 4 times 5 equals, and we get 12 over 7. Okay. And then if you needed to, you could plug this in, but this is still going to turn out to be 12 over 7. So that's going to be my x-coordinate of R. Now, for my y-coordinate of R, I'm doing the same thing. So I'm going to go ahead and get rid of these highlights. And so we're going to take the y-coordinate of P times the weight of P plus the y-coordinate of Q times the weight of Q, and then we're going to divide by the sum of the weights just like we did before. Okay? And then from here, now we're using the y's, so it's going to be negative 3 times 2 plus 2 times 5. So setting up my paper this way helps me with what I'm doing. I'm never going to tell you to do something that's not going to help you out, okay? And so we've got 2 plus 5 here. And now let's go ahead and type that top part into our calculator. Let the calculator do a lot of the legwork, especially when you're doing your EOC. You don't want your brain getting overly tired on doing a whole bunch of mental math when you're allowed to use a calculator. So please, please, please use your calculator, okay? And so this is going to be 4 over 7. Okay, and then let's go ahead and kind of graph this particular point. So that means R, remember this was the x-coordinate of R, so it's going to be 12 over 7, and then we've got 4 over 7. And let's kind of look at what that looks like on our graph. And so 12 over 7, if you kind of need to see what that is as a decimal to help you out, that's 1.71, so around 1 3/4. It doesn't have to be super perfect. So 1 3/4, right? And then 4/7 is, it would be somewhere around here, right? And that's going to be R. If I'm thinking about, is this reasonable? If I'm looking at PR to RQ, and they're telling me that the weight of P is 2 and the weight of Q is 5, that means R is pulling closer to Q because it weighs more. With our section formula, it was a little bit more straightforward, kind of easy to kind of picture and see why it looks the way that it does. And remember, weighted averages do the same thing, but it's more about pulling towards the one that's more important. Okay, and so thinking about, does this look rational? Yes, it does. And now let's get into a real world scenario. So for this one, it says the Bold City apartment complex is located at 14 Greyhound Way, and the Jaguar apartment complex is located at 40 Greyhound Way. So these are addresses, right? These are addresses. And so they're giving us these locations. So you're kind of thinking about if these were houses on a street, one would be at 14, house 14, and one would be at house 40. Okay, so that's kind of one way you can kind of visualize what these look like. All right, and so here's our locations, and then it says the city is planning to add a bus stop on Greyhound Way to accommodate the 12 riders at Bold City and 8 bus riders at Jaguar. So if we're thinking about what this looks like, we've got an apartment complex, right? And this is going to be Bold City apartment complex is here at 14. And then we've got another apartment complex here, which is at 40, and this is going to be Jaguar apartment complex, right? And they're telling us that there's 12 riders at Bold City, and so the number of riders is talking about weights. When we're thinking about where to place a bus stop, we're thinking about which place has more importance. So one of our apartment complexes is more important than the other because it has more riders. And so that's kind of how I want you to view weighted averages in this case. So that means I'm going to go ahead and write out Bold City, right? And Bold City is at a location of 14. And the weight of Bold City is going to be those 12 riders. And then we've got Jaguar, okay, which is at location 40. And the weight of Jaguar is going to be those 8 bus riders. And then we would kind of just do the same thing that we've been doing, right? And so we're going to add those weighted locations. So I'm going to do 14 times 12 plus 40 times 8. And then I'm dividing by 12 plus 8. And so let's go ahead and get this into my calculator. We're going to clear it out. 14 times 12 plus 40 times 8 equals 488. And then we're dividing by 20 on the bottom. So let's go ahead and get that in our calculator. So divided by 20 equals 24.4. Okay. And so thinking about what this looks like on a street, okay, there is no address that's going to be 24.4, right? It's going to be a whole number. And so when we're thinking about where we're placing a bus stop, if we're thinking about these in terms of if these were just houses on a street, that means 24.4, the bus stop is going to be between 2 different houses. So that means it's going to sit between 24 and 25, Greyhound Way. And that's going to be the address of where that bus stop is going to be. It's going to be between 24 and 25 Greyhound Way. And when we're thinking about what that looks like, 24, it's leaning towards which one, right? That means 24, it's going to be a lot closer to Bold City than it is Jaguar. So 26 would be straight kind of in the middle, but we see that it's going to be leaning a little bit towards Bold City. okay? And so that makes sense because Bold City has 12 riders and Jaguar has 8. If it changed, so say maybe in the afternoon or maybe a few years down the line, that changes to where maybe Jaguar adds more housing, or maybe there's a change in the job market where a lot more people are taking the bus at Jaguar, maybe they would consider moving that bus stop closer to Jaguar instead of Bold City. And so this is how these real world scenarios work with weighted averages. So it's not always, oh, I'm just finding the weighted average of, let's say, test scores. That's something we do all the time. But it could be very, very much one of these problems where they're trying to figure out where to locate a business, where to put a bus stop, where an ambulance should be parked. And that's what people do actually for city planning is they're trying to figure out where to strategically place certain businesses or certain parking spots to make things more efficient and to cater to wherever their customer base is, where they get the most business, that kind of thing. I hope that this video was helpful for you in doing weighted averages, and I look forward to seeing you in the next video.